This is Algebra 2, Unit 5, Lesson 5, the rest of the geometric series notes. Okay, so we left off in the video with the two formulas here for a geometric series. So for a geometric series defined by the first term A1 and its common ratio R, that's its multiplier, the sum of n terms is given by. So there's two formulas that you can use. They're the same formula, just one is distributed over the other. So this is A1 times 1 minus R to the n over 1 minus R. Or you can distribute the A1 through here and do A1 minus A1R to the n over 1 minus R. Basically what you're doing is you're taking a geometric sequence and adding up the terms. So instead of having to individually add them up, if you don't know the number of terms, you can use the geometric series formula to do that. Okay, so the notes left off on number 5. So let's take a look at number 5. Maria places $500 at the beginning of each year into an account that earns 5% interest compounded annually. Maria would like to determine how much money is in her account after she made her $500 deposit at the end of 10 years. Okay, so let's determine a formula for the amount, A of t, given $500 grown to, that a given $500 has grown to t years after it's placed in this account. All right, so she started at $500. She is growing 5% interest per year. So overall, what percent would that be overall? So she'd start out with 100% she started with plus the 5%, so that's 105% overall growth. So her multiplier here is going to be 1.05. All right, raised to the t being the number of years. Okay, so at the end of 10 years, which will be worth more? The $500 invested in the first year, or if you invested $500 in the fourth year. So let's see how much is worth beginning of the 11th year. All right, so let's say that she's deposited after 10 years. So that would be 500 times 1.05 to the 10th. Okay, so if I grab my calculator, 500 times 1.05 raised to the 10th power. All right, she would have approximately $814.45. Okay, so this is if she invested at the first year. Okay, so what if she had invested after the fourth year? All right, how many times would she have to multiply if she started in the fourth year instead of the first year? Well, instead of having a 10 here, this would be 6. Because she's not starting until the fourth year, so she would have 6 more years after that to apply the interest. So that would be 500 times 1.05 raised to the 6th power. Okay, so after 4 years, she's going to have $670.45. Okay, so that's how much would be in each account. So which one would have more? It would be this one, because she is investing longer for that particular one. Okay, so based on B, write a geometric sum representing the amount of money in Maria's account after 10 years. Okay, so the sum, the first year she would have $500 times 1.05. That would be the first year. The second year, she would have 500 times 1.05 squared. And then so on and so on, plus ... until she get to the 10th year. And that would be the sum. Now, instead of having to do that every single time, we can evaluate the sum using the formula above. So in this case, this would be at the end of the 10 years. After 10 years would be 11 years. So if we figured S of 11, all right, A1 would be 500 times 1 minus R, in this case we said was 1.05 to the 11th, all over 1 minus 1.05. Okay, so we're just following the sequence or the series formula for the 11th year. So that's how much she would have after the 11th year. Instead of having to evaluate every single one of these up to 10 and then adding them together, you can do this formula. Okay, so all we have to do is pop this in the calculator. All right, I'm going to use my fraction key so I can put it all in at once. Alpha y equals number 1. All right, so it would be 500 parenthesis, 1 minus 1.05 raised to the 11th. Oops, and then close your parentheses. And then divided by 1 minus 1.05. Okay, and then we get $7,103.39, 7103.39. All right, so if she started and individually put it in after 10 years, this is how much money she would have in there. Okay, now you can use them just doing without the fraction key. If you do that, I would do the 500 times 1.05 raised to the 11th, enter, and then divided by parenthesis 1 minus 1.05. Okay, whoops. Oh, I forgot the 1 minus on the first thing. Okay, let's try that again. 500 times 1 minus 1.05 raised to the 11th. Oops. Oh well. And then enter. Oops, that goofed me up there. All right, well, you know what I mean. 500 times 1 minus 1.05 raised to the 11th. All right, that's a negative number, but then you're going to divide it by 1 minus 1.05 would also be negative. And that comes out to be your answer. So make sure that you use your parentheses when you're dividing for that particular one. Or if you're doing it on Desmos as well, you should be able to do it either way. All right, now let's work on the last problem. All right, a person places 1 penny in a piggy bank on the first day of the month, 2 pennies in the second, 4 in the third, and so on. Will this person be a millionaire at the end of a 31-day month? Show the calculations lead to your answer. Okay, so we are looking at a series of geometric series because what are we doing every time? Well, we're starting at A1 is going to be a penny, and then you have 2 pennies and then 4 pennies. So what's happening every time? You're doubling it. So your R in this case is going to be 2. Okay, now your N, how many times we're going to do this? We're going to do this 31 times. So let's use the formula. S of N equals A1 times 1 minus R to the N over 1 minus R. Okay, so again, A1 in this case would be 0.01. 1 minus R would be 1 minus 2 to the N is 31 over 1 minus 2. So how much money do we going to have at the end of 31 days? So if you add the money you have, 1 cent plus 2 cents plus 4 cents and so on and so forth, let's see how much money you're going to have. All right, so again, I'm going to use my fraction key. All right, so it would be 0.01, and then it would be 1 minus 2 raised to the 31 power divided by 1 minus 2. So would you be a millionaire? Yeah, you would be. You'd have $21 million. $21,474,836.47. So after 31 days, you would have $21,474,836.47. So yes, you would be a millionaire after that amount of time. So basically what a geometric series is if you take a geometric sequence and add up the individual terms, you have created a geometric series. There is a formula for that. It is this formula, or you can distribute the A1 and do it as S of N equals A1 minus A1R to the N over 1 minus R. Both of these formulas are the same. The one that's on the Regents reference sheet, if you want to see it, is this one, but both of them work just fine. Okay, so that's all your homework about geometric series.